On December 25th, 2021, humanity launched a time machine. We didn't build the James Webb Space Telescope just to see further into the dark. We built it to answer the oldest question of our species. How did this begin? We wanted to witness the first light, the precise moment the universe switched on after the Big Bang. Scientists had a very specific prediction for what we would find. Based on every model of cosmology we have written over the last century, the infant universe should have been a dark, quiet place. It should have been filled with thin. These heavy seeds would have acted as anchors, pulling entire galaxies together around them. It changes our understanding of galaxy formation from a slow, graceful dance into a violent, gravity-driven car crash. We used to think galaxies created black holes. Now it looks like the black holes might have created us. But the strangeness of the early universe doesn't end there. Webb has spotted candidates for the holy grail of cosmic horror, dark stars. A dark star is a theoretical monster powered not by fusion, but by the annihilation of dark matter. A single dark star would be large enough to swallow our entire solar system, stretching out past the orbit of Saturn. They wouldn't be hot and yellow. They would be cool, puffy clouds of invisible matter glowing with a ghostly infrared heat. If Webb confirms these, it proves that the universe was once ruled by a shadowy force we still cannot touch. But dark matter isn't just fueling stars. It is building a cage. Webb is mapping the cosmic web, the invisible skeleton of the universe. We can't see dark matter, but we can see its gravity bending light. Webb has found that this web is tighter and more developed in the early universe than it should be. Massive filaments of dark matter connect galaxies across billions of light years, funneling gas into them like a cosmic umbilical cord. It implies Webb isn't just looking at the beginning of time, it is looking for us. Or rather, looking for neighbors. We pointed the mirrors at the TRAPPIST-1 system, a family of 7 Earth-sized planets just 40 light-years away. We hoped to find atmospheres, water, maybe even signs of life. But Webb delivered a crushing blow. It looked at the innermost planet, TRAPPIST-1b, and found nothing. No atmosphere, just a bare, burnt rock. Then it looked at TRAPPIST-1c, again, bare rock. It was a stark reminder that the universe is hostile. However, hope is not lost. Webb turned its gaze to a world called K2-18b. This is a Hycean world, a planet covered entirely in a massive, deep ocean under a thick hydrogen atmosphere. Webb sniffed the air using spectroscopy and found methane and carbon dioxide. But buried in the data, it found a potential signal for a molecule called dimethyl sulfide. On Earth, this molecule is only produced by one thing: life. Specifically, phytoplankton living in the ocean. If confirmed, this detection changes human history instantly. It would mean we are not alone. But there is a catch. We are seeing this signal from 120 light-years away. By the time we could ever send a reply. However, the most disturbing discovery isn't a planet or a star. It is a number. We use the Hubble constant to measure how fast the universe is expanding. We thought we knew the speed of our reality based on the leftovers of the Big Bang. But when Webb measured the expansion using nearby stars, it got a different number. A significantly different number. The universe is expanding faster than it should be. The data from the beginning of time doesn't match the data from today. This discrepancy is called the Hubble Tension, and it implies something terrifying. We are missing a piece of the puzzle. To fix the math, physicists have proposed early dark energy, a mysterious force that might have existed shortly after the Big Bang, shoving the universe apart violently before vanishing. It's like a ghost in the machine of reality. If this force existed, it means the fundamental laws of physics are not constant. They change. And if they changed once, they could change again. The false vacuum could decay, or dark energy could tear the universe apart in a big rip. Webb is staring at the cracks in our model of the universe, and the cracks are getting wider. We built the James Webb Telescope to confirm what we already knew. Instead, it has humbled us. It has shown us galaxies that shouldn't exist, stars made of darkness, black holes that grew too fast, and signs of life in the void. We are realizing that our standard model of cosmology might just be a comforting story we told ourselves because the truth was too complex. The universe is not quiet, it is not empty, and it is certainly not simple. As we stare deeper into the abyss, looking for the first light of dawn, we are finding that the night is full of terrors and wonders we are only just beginning to understand. The telescope has done its job. It broke the universe. Now, it is up to us to put the pieces back together.